Hello and welcome back. Today in module number 12, we are going to talk about time series, but we are going to add a little dimension to it where we are going to talk about the art of forecasting and what does it entail to forecast and how do we apply modeling or modules in order for us to do that. This is almost the end of the semester, so we'll try to do as comprehensive as I can. I know that I will jump between concepts, but I will try to go back and forth and back to it. The first series in this PowerPoint presentation is to give you the foundation of time series. What does it entail? Why are we doing that? What is the formula that we are applying? So it will give you some basic foundation to what we are doing, and then I will take it to R. I will try to follow up a very good book about time series in R. I will not use my own textbook because I think this text is more comprehensive with regard to the R. And in the end, I will also talk about your assignment with regard to the class. So again, this is about model time series and it's about forecasting. It is more advanced. This is the most advanced subject. Next time we're going to talk about modeling and what does it entail. So you will have at least strong understanding what is modeling in statistics means. So in this module, I will talk about different type of time series models. I will talk about moving averages. I will talk about exponential smoothness. I will talk about trends. I will talk about regressive models, and I'll also talk about the most appropriate time series model. How do we choose it? How to apply that? So you will at least have some background how to apply or discuss it, because I'm quite sure that in your next job or in the next job you will encounter that any type of time series modeling, and you probably will need to develop some ideas. So what is the goal of time series? We have at least five objectives. First of all, the first objective is descriptive. We need to identify patterns in correlate data, trends and seasonal with regard to the data and its variables and how they apply. We need to provide explanation, understanding and the modeling of the data. How do we model the data in order for us to apply that? We also need to talk about forecasting, which is a prediction of a short-term trends taking from the past in order for us to make prediction about the future. We need to talk about intervention, which is discover if a single event changes the time series, and the most important, like some of you coming from a background in computer science, we have quality control, and we have to identify specific size indicate of a problem that might cause if we are using time series modeling in order for us to do that. Why are we learning about time series and forecasting? First of all, if we will do a survey, all type of business and governmental use time series. Colleges administration use time series. Marketing, government, retail, and I'm sure even politicians do that in order for them to be more prepared what will be the next move. There's two types of approaches of forecasting. I will not talk about qualitative forecasting because this is not the class to talk about that. This is probably a class that you will take in your graduate class that will talk about more personal data, personal interpretation, and so on. I will talk about time series with the idea of using the data to make predictions about the future, and by doing so, I will be able to show models that we can apply. The type of data we are usually applied to is numerical data. which is usually at a regular time, be collected, example, annually, quarterly, monthly, weekly, daily, hourly, and so on and so on. So in this case, I'm using old data that when I started my PhD, I had the data from 2005, and so this is what ended up in this presentation. And so time plot, in this case, is the visual representation, and in this case year and inflation rate, and you have the X and the Y, and this is where we can see where is the trends are trending right now. So the components of time series is the trend, the seasonal, the circle, and irregular. All of them will play part in my PowerPoint presentation, and I hope that you will have a sense of the components of time series. It's not one dimension, it's not one you collect the data and that's it. You have to understand what is the trends, what is the difference between the collection and so on. So the trend component is the run increase or decrease over time upon upwards or downwards movement. So the data is taken over a long period of time to collect and to be analyzed. And so it is a long run and it doesn't apply. Trend, in comparison, can be upward or downward, like we see regular, but it can also be non-linear, which means that it can have outside values that are not part of the trend or the linear trend that we are looking for. So this is the trend components that we need to apply or understand when we see the data. Seasonal is a short term, a regular wave, they call it in old statistical textbook. It's like patterns, and so it's observed within 1 year, often monthly or quarterly, and we can see winter versus winter, summer versus summer, and this is spring versus fall, and so on and so on. Often, me as a faculty at this university, I've been measured by seasonal components. I've been measured in the spring, I've been measured in the summer, I've been measured in the winter, and every time they're trying to see where I'm heading and what do I do in my time. So another component is a circle component. It is a long term. It is a wave, like again, it is the length of a circle within a year. So one circle is the highlight. This year, for example, I published a lot of articles, but the circle was only through 6 or 9 months. So taking those circles into 9 months, will be a circle. This will be the circle that we will look at in order for us to analyze the data. Irregular components is outsider, something that we are usually said it is unpredictable and something unrealistic, and so we call it a lot of time we're talking about noise that in time series it's a serious business. If you will register for my next class in open source R programming, you will see how we dealing with noise in the data and how we clean it in order for us to overcome this problem. And data science, noise is a big problem, and R has a lot of quite nice solution into it. So does the time series have a trend component? The plot should help you to understand or to answer this question. So basically, the visualization of the time series help us to see what is the trend and how we apply to it in order for us to understand. So two popular smooth methods are moving averages and exponential smoothness. I'm going to help us to understand this question, and we are going to talk about, I'm going to repeat the term smooth again and again, And this is the trends. We are going to try to understand the trends in the time data that we have with regard to time series analysis. So the smoothing methods, we have two types of methodologies. One is a moving averages. We calculate moving averages to get the overall impression of the pattern of the movement over time. The averages is the value chosen by the period of time we are looking at this type of data. You cannot go overboard, you have to be very specific. In comparison to moving averages, exponential smoothness is the weight moving averages. So it's a different calculation that we apply to in order for us to do that. In moving averages, we are using the smoothness. And so we're using the result depend on the choice of L. L stands for the length period of computing means, and the L is also the length of one period into the future. So example, in 5 years, the L will be 5. In 7, the L will be 7. So in this case, 5 years moving averages, we will collect the averages of each year and we will divide it by 5. And second averages, the same thing. We will need to have consistency with 5. So in this case, the second averages will be 2, 3, 4, 5, and 6, compared to the first averages is 1 to 5. So as you can see, using a 5-year conservative structure, we are able to apply that and to find the moving averages. So in this case, this is annual data. But if we will calculate the moving averages, and again, it has to be 5, because this is the set that I told myself that I need. So it will be 5 variables that I will divide it into. So in this case, each one of them will have 5 values that will be divided to 5. So again, if we will compare what I have found with regard to moving averages, which is the red line, you will see that the averages compared to the moving averages is a little bit different. So again, it makes the whole structure or understanding of the data a little bit different when we are talking about moving averages. Exponential smoothness is the use of a short-term forecasting, one period into the future. So what we are doing basically, weight moving averages, we are most recent observation is giving the highest value, and by doing that we are applying the smoothing coefficient, which is W. It is subjectively chosen. It ranges between 0 and 1. Smaller W give us more smoothing, larger W give us less. And so in this case, when we are getting closer to 0, it's unwanted, and when we are getting to 1, it is the forecast that we are trying to do. The model, the formula that we are applying here, it's a little bit messy. It's really hard to write formula in PowerPoint, but this is the best I could come up with. And so in this case, we have variables that we need to calculate in order for us to apply that. And again, in R, I will show you a smoother way to do that, and it is going to be another example why R is so important in learning statistics. So in this case, this is the weight, the W, the E, and all of it. So basically what we will find in this case, we will find the value of the forecast, we will learn about the exponential smoothness value for this period, and we'll be able to calculate it in order for us to do that. So again, sales versus this type of analysis, and as you can see, the smoothness value in this case generally a little low, since the trend is upwards sloping and the weight factor is only 0.2. So again, this is something that we need to take into account, need to be aware of when we are trying to understand cells, and that's why we often use the smoothness functions or operation in order for us to do that better. When we do a forecast time period, we are often talk about I plus 1. So the smoother value of the current period, I, is used to forecast value for the next period, which is I plus 1. So in this context of the Y and the E, this is where we add the components of the I and the I plus 1 into our equation. We have three types of methods based on forecasting: linear trend forecasting, nonlinear, and exponential trend forecasting. Linear, I hope that by now you understand. Nonlinear is again with external or extreme value outside the averages. So in this case, it's a nonlinear forecasting, and we need to deal with that when we have this type of data, when we were trying to predict what will happen next. And exponential trend forecast, you'll see why is it so important. So in linear trend forecast, we estimate trend using the regression analysis, using the time as a x, and in this case, this is our formula, and the latest square linear, or the nonlinear, or the exponential linear time series number starts with a 0 and increases by 1 for each period of time. So in this case, this is what happened, and we are able to calculate what is the value of the 21.905 and 9 plus 9.557, and we are able to predict what will happen. So again, using this formula, we are able to have some values that help us to calculate what will be the next year or the future predictions about 2010. And so in this case, the forecast time for the period 6 in this case will be the 21 plus the 9.9, which will give us multiplied by 6, it will give us the 97.33. So this is the multiplication, and by idea of forecasting, again, this is the equation. In this case, we need to apply the x power by the I in order for us to do the right calculation, in order for us to find that, in this case, the future value of the cells in 2010 will be 79.33. I want to apologize. I wrote this example long time ago when I started my PhD. I did not update that. Using PowerPoint is really hard, so I do apologize that the dates are not correct. It's supposed to be instead of 10, it's supposed to be 18, and instead of 2004, it has to be beforehand, but this is not the issue. The issue, I want you to show you the idea of how do we do that. When we are doing nonlinear trend forecast, we are talking about another type of formula. It's not the same formula, it's another formula that allowed us to apply nonlinear data into our equation. So we are doing it to other functions formed to best fit into this type of data. So this is the formula. I'm not going to talk about that. I'm not going to show you an example because it's a little bit more complex, but I'm going to talk about exponential trends model. And it is another nonlinear model, and so I'm combining it together. So the transformation to a nonlinear, it is as follows. So in this case, I apply the exponential trends model into nonlinear in order for you to apply that. So in this case, what we have here is quite a lot of variables that we need to be aware of, where the B0 is the estimate of the log, the B1 is the estimate of the log B1, and the interpretation, we need to do that in the context of percentage, which is the estimate annual compound growth rate in percentage. And so the trends model section using the difference is the following trends, and this is the following formula. I'm not concerned if you will not remember. I'm not going to quiz you. This is not the objective. What I want you to have is this idea of how we find it and how we apply that in order for us to find the trend model section and how to do that. Another model that we need to talk about is autoregressive model, and it takes advantage of the autocorrection. So in the first order correction of consecutive value, the second, and the p. But in this type of error, why is it so popular? Is that random error, it has to be encountered as part of the formula. And so again, this is something that we need to be aware of. And in this example, I showed you again office occupation and the last 8 years, and we developed a second order autoaggressive model in order for us to do that. So in this case, this is a table. We have to have the table set up. We have the x variables, and we have the x variable 2, and we have the coefficient. And so in this case, we will use the R to do the regression model in order for us to calculate that. A textbook that we are going to read talks about that, talks about this model in the R, and see how it is to do. But in this case, how do we apply that if we did not have the R? We had to have all the values into place, and we will need to apply 3.5 plus 2009 plus minus 2008, and will give us the value in order for us to find what is the value of 2010. So the steps that we often entail in autoregressive modeling is that we need to choose the P. We need to know that what is the degree of freedom, which is equal to the n minus 2p minus 1. And from standpoint of predictor, we have the y and the y1, y2, and yp, and we are using the R to run the regression analysis using all the p values. So in the end, what we will come up with is a test significant of p by the power of p, a by the power of p. And so if the null hypothesis is rejected, this model is selected, and I want you to remember that. And if the null hypothesis is not rejected, it decreases p by 1 and repeat the process again. I said in the beginning, how do we choose a model, a forecast model? We need to do analysis. We need to estimate the model that show a patterns or a trends. We need to measure, and we need to be aware of errors with regard to residential error, that using square differences and select model with the smallest value. And we need to measure magnitude of the error using the absolute difference and the select model within the smallest value. My recommendation is use the simple model. I wrote the principles of parsimony. I will talk about that in 2 seconds, but again, use simple model that you'll be able to have more control of it is usually a best resolution. Residential analysis has often happen with random errors, circle effect that not count for, a trends that not count for, and seasonal effects that not count for. The measuring of error, we have 2 types, and this is something really important that you need to envision, that you're going to develop your own model one day. And so what you need to make sure that you are measuring error. And so the sum of square error, it's usually sensitive to outlier, and comparison, the mean absolute deviation, or the MED, is less sensitive to extreme observation. So both ways, I will show the textbook, I'll show you an example of that, so you will be able to do that. I talked about the principle with regard to choosing the right model. And suppose you have 2 or 3 models provide a good fit for the data. The select the simple model is that at least this least square linear, at least it has the first order of auto-regressive, and more complex type has the second and third order of auto-regressive, and you have squares exponential into that account. Again, I'm not concerned right now, but again, the book online will give you a big explanation on that. What I want to do is I want to talk about forecasting with seasonal data, and this is something that happens to me again and again with data that I'm asked to analyze. Time series is often controlled monthly or quarterly, and so time series often contain a component of a seasonal component, which means that it is a irregular component. So suppose the seasonal is quarterly, you need to define new dummy variable for the quarters in order for you to make sure that when you use seasonal data, you will not make an error, you will not make a mistake out of it, and you will define quarter 1 is the first quarter, 0 is otherwise, quarter 2 is 1 if second quarter, 0 otherwise, and same goes to quarter 3, and then you will defined as quarter 1 equal quarter 2 equal to quarter 3 equals 0. So exponential model for quarterly data consists of the following formula, and it transforms to a linear form, and this is what it entails. And so the idea here is that we have interpretation to the model and how it apply to with regard. I don't expect, again, I'll repeat it again, I don't expect you to remember this model. I don't expect you, this is for advanced statistical course, and this is just give you a sight of what we are trying to achieve when we are developing our own model. So again, interpretation and what does it entail. But I want to finish up with the pitfalls of time series. And one of the things that it is something that we are assuming is that there is a mechanism that governs the time series behavior in the past will not hold in the future, and this is a good sentence to remember. And again, one of the things that usually we encounter in time series, and it is a pitfall, is that we are considered personal or judgment or business experience or changing technology or habits, and it can be sometimes something that will affect our result. In R, I want you to take a very close look at the little book of R for time series. It's by RVL of Glenn, and this is the website. I will share the website with you. He was so kind that what he did was giving the data using the R. So basically, instead of saying, okay, the data is in Excel, I need you to import that into R, no, he said, I will give you the data in the R format, and so instead of reading the data, you scan the data, and it will give you the following data. So, and again, he uses a function called TS, and it stores the data as kings in that type. So in King's time series, he embedded the TS, and so it's become a function, and by doing that, he was able to apply that. The next is, again, very easily apply it to plot in order for us to see what is the data consists of. And exponential smoothness, he goes through several procedures in order for us to apply the exponential smoothness in R. So we need to apply. What is it entail? He uses a function called hot winters, which is parameters that already is a function in R that has a force of data and a gamma of force, and when you apply that, he will embed the analysis into that function in order for you to apply and find the result. So in this case, we define that, we apply that in order for us to find the coefficient, we find the alpha, something that it's really hard to do when you are running Excel or SPSS. So again, in this case, the alpha is about 0.025, which is very close to 0, telling us that the forecasts are both recent and less recent observation are something that we need to take into account. But the hot winters just makes forecast the same period over time, and this is something, again, I want you to pay attention when you will do analysis. So in this case, we start the analysis, we run the analysis, and my recommendation is apply that and to see what does it entail. This is really good resource in order for us to do that. So this is it for this module. I know it was long. I know it was going to be a hard subject. You're going to eat your nails. But again, I want you to experience this to understand what people in data science or business analysis do day in and day out with regard to the data. Until next time, I hope you have a nice week. See you soon.